now we can use alternate approach. So it is very simplified way for beam and rigid frames. The element of the flexibility matrix Fij equal to Fji is equal to integration of Mi into Mj into dx divided by Ei, where Mi represents bending moment at any point due to unit force at coordinate I. Mj represents bending moment at any point due to unit force at coordinate j. Ei represents flexural rigidity. Then one important condition is the integration must cover the entire structure. So for this is our given example. This is our given example. So to develop the flexibility matrix for the beam coordinate as shown in figure. So in this figure they have shown 3 coordinate direction. So therefore the order of the matrix is 3. Then the flexibility matrix is a 3 by 3 square matrix. Okay. So for this, so first we have to make a table. We have to make a table like this. So first column of the table is portion, second column will be origin, third column will be limits, then fourth one is M1, M2, M3. So in this problem they are shown only 3 coordinate direction. So therefore we can write the table up to M1, M2 and M3. So in some other problem it may be shown only 2 coordinates. So that means we make a table up to M2. So sometimes 4 coordinates means we can write a table up to M4. Okay. So M1, means the bending moment. So M1 means bending moment at a point due to unit force at coordinate 1. Unit force or unit moment at coordinate 1. M2 means bending moment at any point due to unit force or unit moment at coordinate 2. M3 means bending moment at any point due to unit force or unit moment at coordinate 3. So first we have to develop that M1, we have to determine the M1 value. So M1 means I already said it is the bending moment at any point due to, so bending moment at any point due to unit force at coordinate 1. So in the given example, so this is coordinate 1. Okay. So coordinate 1 is a clockwise moment at end A. So first we have to apply a unit moment at A, then determine the bending moment in AC portion and BC portion. Okay. Then for so for this so apply unit moment at support A, then determine the support reaction, then determine the bending moments in AC portion, then BC portion. So these things we already determined. So that's why I simply written the portion is AC portion, then limit origin is A, limit is 0 to L by 2, M1 is equal to 1 minus x by L. Then for BC portion origin is B, limit is 0 to L by 2, M1 is x by L. Then again we have to determine M2 value. So for this we have to apply unit anti-clockwise moment at support B, then determine the M2 values. Okay. Then M3 values is determined from applying unit force. So unit force at the midspan. Okay. It gives bending moment in AC portion is equal to x by 2, then BC portion again x by 2. So this thing we already determined. So that's why I simply make the table. Then finally F11 equal to integration of, so we know the general formula Fij is equal to integration of Mi mj dx divided by ei. Okay, this is general formula. So now we are determining f11 is equal to integration of m1 into m1 dx divided by ei. So substitute m1 values, then corresponding limits. Finally we determined f1 is equal to L by 3 ei. Then f22 is equal to integration of m2 m2 dx divided by ei. Substitute these values. Finally again f22 is equal to L by 3 ei. Then f33 is equal to integration of m3 m3 dx divided by ei. So substitute the values. Then finally f33 is equal to L cube by 48 ei. Then f21 is equal to f21 and f12 is equal to integration of m2 into m1 dx divided by ei or m1 into m2 dx divided by ei. Substitute these values. So the final f21 and f12 is equal to L by 6a. Then f13 is equal to integration of m3 m1 dx divided by ei, which is equal to m1 m3 dx divided by ei. Substitute these values. Finally f13 and f31 is equal to L square by 16 ei. Then f23 f32 is equal to integration of m2 m3 dx divided by ei. Put its value, then finally it is L square by 16. Finally the flexibility matrix F is equal to L by 3 ei, L by 6 ei, L square by 16 ei. The first column. Second column will be L by 6 ei, L by 3 ei, L square by 16 ei. Then third column L square by 16 ei, L square by 16 ei, L cube by 48 ei.